Hi everyone, I hope you are doing well. As I promised you, this video will be dedicated to numerical examples or exercises on price volatility. So remember, this chapter 4, is dedicated to explain how shall we measure and how shall we treat, the bonds price volatility. We have learned two new concepts, which are duration and convexity. So we have shown that these two concepts put together can, be a very good and let's say uh, more or less accurate tool in order to assess the bonds price volatility as well as to estimate the future, variation in the bonds price following any variation in the yield rate. So remember that during the two past lectures, we have tried to get more familiar with these two new concepts, duration and convexity. We have learned, the theoretical fundamentals of these two concepts. Now we have done this. Let's move to the practical feature or practical aspects. Let's resolve some exercises and know how to put into practice all this new theoretical knowledge that we have reviewed during the two past lectures. So I invite you to to resolve the two exercises number 2 and number 4 in page 90. Okay, so the exercise number 2 that will be resolved during this video is about how to compute duration and how to compute the convexity measures, and then how to compare duration and convexity for different bonds and how to interpret these results. While for the exercise number 4, which will be treated in the next video, we will deal with how to use convexity as well as duration measures in order to assess the price volatility of the bond, in order to to understand or to use these two measures to forecast the price or the bond's price change following a yield rate change. So let's start with exercise number 2. Okay guys, so welcome back. So let's move to the exercise number 2. See, so this one. So we are asked to calculate the requested measures for bonds A and B, assuming that each one of these two bonds is paying interest or coupon semi-annually. So A is offering 8% coupon rate while B is offering 9%. For both of these two bonds, we will use a yield to maturity equal to 8%. A has a 2 years maturity while B has a 5 years maturity. The two bonds have a par value of $100 and the current price for A is $100 while for B it is $104.055. So the first question is the price value of a basis point. So we mean by price value of a basis point the change in the bond's price following a variation of 1 basis point in the yield to maturity. Remember, 1 basis point is equal to 0.01%. This means that instead of using 8% as yield to maturity, we will use now 8.01% as yield to maturity. Then verify the new prices of A and B, compare these new prices to the current prices. The change of the bond's price represent what we call the price value of a basis point. So to do so, I will use Excel. So the good thing with Excel is it is a faster and safer way to make calculations than compared to the calculator. So I will zoom in so I make the cells clearer for you. So let's start with this new task. Remember, we are asked to compute the price value of a basis point. So we will start by the bond A. So I will, copy all these information related to A in the Excel sheet. So we have the coupon, we have the yield to maturity, we have the maturity in years, then we have the par value, and finally the current price. So the coupon is equal to 8%. Same thing for the yield. The maturity is 2 years. The par value is 100, as well as the current price. So the first thing is that we have to, first convert these rates, which are annual rates, to semi-annual rates, because the coupon or the bond A is paying, interest semi-annually. So this is for the coupon, sorry. So these are annual rates for both coupon rate and yield rate. And we have to convert them into semi-annually. So this one will equal to, so we have here. So the coupon semi-annually and the yield semi-annually for what the number of periods will be the double of the number of years. So for the coupon rate, it will be equal to the annual coupon rate divided by 2. For the yield rate, semi-annual yield rate, it will be equal to the annual yield rate divided also by 2. And while for the number of periods, it will be equal to the maturity times 2. Now, the first task will be computing the new price of the bond A when the yield, the annual yield, will move from 8 to 8.01%. So this is the new yield on annual basis. So remember, we are looking for, the price change following 1 basis point change in the yield, which means that the new yield will equal to the current one plus 1 basis point, which is 0.01%. So here we are, a format issue. So it is just considering the number without decimals. So in order to get more, more decimals, we have to increase decimals, see? And we have here 8.01%, which also means that the semi-annual yield, the new semi-annual yield will be equal to the new annual yield divided by 2. So this is the new yield. Now let's start by computing the new price of the bond. As we have seen during the first and second chapter of this course, the fair price of a bond is composed by 2 terms. The first term is relative to the coupon payments, while the second one is relative to the final payment. So the coupon payment is what we call annuity, because it is the same amount of money paid regularly every semester, right? So let's compute the coupon payment. It is equal to the par value, right, times the coupon rate on a semi-annual basis. So this means that this bond will pay regularly $4 every period, every semester. Once we have this, we can compute the present value of all the coupon payments through the maturity of the bond. So we have a formula to do it. Remember, the present value, see, interest factor annuity, because we are paying the same amount of money. This is an annuity of $1. It is using a discount rate equal to K. All right. So it is 1 minus 1 divided by 1 plus K power n divided by K. All right. So this is the formula. So if we want to translate this formula into the data, or to the data of our exercise, so the K, which is the discount rate, will be replaced by the yield to maturity, while the n will be replaced by the number of periods, right? So all we have to do is to rewrite this formula, right, into Excel. And to pay attention also, we have to pay attention, because this formula is for an annuity equal to $1, while our annuity is equal to, say, $4. So this is the repetitive coupon payment that the bond A is offering to the bondholders, right? So let's start by calculating the present value interest factor annuity, right? So as I told you, we'll just rewrite this formula using Excel. So we open the parentheses, 1 minus 1 plus the yield to maturity. Remember, we have to use the semi-annual yield to maturity, the new one, this one, see? So power the number of periods, see, it's the number of periods, divided by the yield to maturity. This one is, sorry for the, we should add minus, so power minus number of periods. And this is the present value factor for an annuity of $1. So in order to have the present value of all coupon, all we have to do is just to multiply this present value factor by the amount of the coupon payment, and it will equal to 14.51787. Then we also have to use, or we have to to compute also the present value of the final payment, which is equal to the par value divided by 1 plus the yield to maturity power the number of periods. All we have to do is to sum up the present value of the coupons plus the present value of the final payment to get the new price of bond A. So the coupons plus the final payment. So see, when the yield to maturity was equal to 8%, the price was equal to $100. Now that the yield has increased by 1 basis point, the price has decreased and moved from $100 to $99.98. So this means that the price value of a basis point, so the price value of 1 basis point, so I write it BP for basis point, for the bond A it is simply equal to the current price minus the new price, and it is equal to 0.0181473. This means that every time that the yield to maturity will move by 1 basis point, the price will move in the opposite direction by 0.0181. For example, here the yield to maturity has increased from 8 to 8.01%. Consequently, the price has decreased, see the opposite direction, from $100 to $99.982 approximately. So this means that the value of 1 basis point for bond A is equal to 0.0181. Now let's do the same thing for the bond B. So in order to save time, I will copy and paste, the same cells. So the difference between A and B is in terms of coupon rate and maturity. So the coupon for B is equal to 9%. Sorry. 9%. See, once I have changed the 9% here, Excel automatically changed the semi-annual coupon. So it was 8% first, right? So with 8%, the semi-coupon payment was equal to 4%. Now, I will replace 8% by 9%. And Excel will automatically bring the required modifications on the coupon interest payment, coupon interest rate. Sorry. So the yield will remain the same. Now the maturity is equal to 5, which means that number of periods, see, shall increase to 10. See, now the current price for A is 104.055. This is the new yield, the new semi-annual yield. Now the coupon payment also will change since the coupon rate also has changed. So it moves from 4 for A to 4.5 for B. Now the present value, see here, it was equal to 3.6294 because the number of periods were equal to, so E5, see, the E5 which is 4. Now using the bond B data, we no longer use 4 but 10. So it says K10. See? So it has automatically been modified by Excel. So this is the key 5 number of periods. And we have key 10, which is the new yield. Same thing for the final payment. So it is equal to H6, which is the par value, divided by 1 plus K10, which is the new semi-annual yield, power K5, which is number of periods. So the good thing with Excel, it is, so as you can clearly see here, that Excel will allow us to save a lot of time. So this is a new price, which is the sum of the present value of coupons and final payment. And this is the price value of 1 basis point of bond B. So replace the A by B. And it will be equal to the current price H7, so the cell H7, minus the new price, the cell H18. See? So this is the price value of one price, not price, of 1 basis point for bond B. So as we can clearly see here, the bond B presents a high volatility compared to bond A, because for the same change in 1 basis point, the bond B experiences a change in its price more than 3 times than bond A. And this is understandable because as we can clearly see that here that the bond B presents a higher coupon rate compared to A, and also a higher maturity compared to A. Remember what we have learned during this chapter, that the bond's price volatility is conditioned among other factors by the coupon rate and the maturity of a bond. Every time these two factors will go up, so it would be for the the bond's volatility. So this is for the first task. Okay, so now let's move to the next question, which is the Macaulay duration, then the modified duration. So remember, these are the key formula for the duration, right? So this is how we compute the Macaulay duration, and this is how we compute the modified duration, right? So let's start by the first one. So we can, divide the Macaulay duration into, 3 components. So this is the first one related to the coupons, see? This is the next one related to the final payment, and this is the third one, which is the current price. So let's try to compute the Macaulay duration step by step. So we'll start by computing the first component, this one related to the coupon. So in order to do so, we need the T, which is the time, we need the C, which is the coupon payment, and finally we need the yield, right? So these are the 3 inputs that we need to have in order to compute the first component. So let's start. So I will keep the same, Excel workbook. I will open new sheet. I call it duration. So let's start with bond A. Okay. Now I will build a table using Excel. The first row is T, which is the time. Then the second row is the coupon payment. Then the third row is with 1 plus y power t. 1 plus y, which is the yield, power t. So this is the first component, right? So the number of periods for a, remember, is 4 periods. So 1, 2, 3, and 4. While the coupon payment is equal to 4. Now remember also the yield to maturity, the semi-annual one, is equal to 4%. So 1 plus 4%, which means 104 power t. Sorry, so I have to put the equal sign here so I can use equation power c. Now I don't need to repeat the separation, for every row, so I will just use it for the first row. Then I will scroll down, see, and it automatically compute the following, present value factor. Now remember, the first component of the Macaulay duration is equal to t times c, t times c, divided by 1 plus y power t, divided by this one. So I will call it the first term, or the first component of the Macaulay duration. So equal t times c divided by the present value factor. Now I have to sum up all these numbers. So the sum, so equal sum, see, so the good thing with Excel it is that that Excel will give you always some recommendation about the desired function. So the sum, all I have to do right now is just to select the required cells, and that's it. So this is the first component for the duration. So this is the first component of the duration. Now let's move to the second one. Second component, see, which is the par value divided by the final period, multiplied by the final period and divided by 1 plus y power the final period. All right, so we have m, which is the final payment. So we will receive nothing during the first 3 periods, and we receive the par value by the end of the final period. We have also here 1 plus y power n. So n is the final period, so we'll have nothing here. Sorry, 0, 0, 0. And for this one, it's equal to 104 power 4, which is the final period. Now, see, we have to multiply n by m first. So n m this is equal, the final payment by the final period. Now all that I have to do is So second component is equal to C, second component, n times m, which is this one, divided by the n plus y power n. That's it. This means that the second component, while this one is the first component, so the Macaulay duration is nothing but the sum of these two components, right? Plus this one the sum divided by the current price, which is $100. So the current price is already given in exercise. So this is the current price, $100. So this is the semi-annual Macaulay duration. So in order to have the Macaulay duration, or the annual Macaulay duration, we have just to divide by the number of periods, which is 2. So equal the semi-annual one divided by 2. So 1.8875. So this is the annual Macaulay duration, right? Now the modified one, so remember the modified duration is simply equal to the Macaulay duration divided by 1 plus the yield to maturity used in the duration calculus. So equal this one, the Macaulay, divided by the yield to maturity is 4% that you have used here. So divide by 1 plus y, which is 104. And this is the modified duration, 1.8149. Okay, guys. Now all we have to do right now is just to repeat the same process for the bond B. And that's it. The bond B, so we have just to pay attention to the number of periods, to the coupon payment for each year, right? And that's it. So, and we should just repeat the same process. So the Macaulay duration for the portfolio B will be equal to annual one, 4.154, while the modified duration is equal to 3.9944. So this is for the bond B, right? Now let's move to the final question, which is about convexity. So we will skip the questions D, C, and F. So let's go to the E, which is the convexity measure. Remember that for convexity, these are the key formulas, right? So it's the convexity measure. So this is the second derivative of P by the yield rate of return times 1 by P. See? So we have first to compute the second derivative, and this is the formula for the second derivative, the 4.21. So the second derivative is almost similar to the Macaulay, duration formula, except that instead of multiply T by C, we add a new, element, which is T plus 1. Also, instead of dividing by T, 1 plus y power T, now it is power T plus 2. See? Same thing for the final payment. We will add the n plus 1 on the upside, and we'll add the plus 2 in the power factor and the downside, right? So let's start with the convexity measure. So as I told you, we'll start first by computing the second derivative. Once we have done this step, we'll just divide by the current price of the bond, and we will get automatically the convexity measure. So let's start by the second derivative. So let's open a new sheet and name it convexity. Let's zoom in. So we will start by doing the required task for bond A. So we'll also build a new table. The first row will be for T. See, so we need the T, we need also the T plus 1. So we'll build another one, T plus 1. Then we need the coupon payment, the C. Then we need the 1 plus y power T plus 2. So 1 plus y power T plus 2. This is for the first component. We also need to have the final payment and the 1 plus y power n plus 2. So we have here the final payment and also the 1 plus y power n plus 2. So 1, 2, 2, 3, and 4. Well, for T plus 1, we have just to consider the previous column plus 1 and scroll down. Remember, the coupon payment for A was equal to 4 and it is constant through all the maturity. Now the 1 plus y power T plus 2. So remember, 1 plus y is 1.04 power, so open the bracket, open the parenthesis, T plus 2. Then we scroll down. Now the M, which is the final payment, we want to receive any final payment during the first 3 periods, and at the end of the final 4th period we will receive the final payment or the par value payment. Same thing here. So equal to 1.04 power n, which is the final payment period, plus 2. So I will open parentheses here. Now see, I have to sum up the, so I have to use, see, I have to compute so the first component. I will call it the first component, first component. So it is equal to T, see, T times T plus 1 times the coupon payment divided by 1 plus y power T plus 2. And I have just to scroll down and compute the sum. So sum of these 4 cells, and this is the first component, 130.305. Now the second component is n. So the second component so it will be equal to C n, which is 4 times n plus 1, which is 5, times the final payment, which is 100, divided by 1 plus y power n plus 2. See? So this is the second component. This means that the second derivative function is, yes, it will be, reached by adding the first component to the second one. So equal to the first component plus the second one. Now, once we have the second derivative, we'll just have to divide it by the current price of the bond to get the convexity measure. So equal, divide by 100, which is the current price of the bond, so 17.109. Remember, this is the semi-annual measure, so we have to convert it into annual measure. And to do so, we have to divide the semi-annual by the square of the number of periods, right? Not just the number of periods, because for the duration, we have just to divide by the number of periods, which is in this case is 2. We have 2 periods for each year, right? Now we have to divide by the square of the number of periods, which is 4. 2 squared is equal to 4. So equal to the convexity measure, semi-annual convexity measure divided by 4. And this is the convexity measure for the bond A. Now all we have to do is just to repeat the same process with the bond B. The work for bond B, see? So the convexity measure, the annual one, is equal to 19.763. So anyway, I will send you, the Excel file, so you can follow all the work step by step, right? So that's it, guys. So this is all for, the exercise 2. Okay guys, that's all for today. I hope you will find this video helpful, and see you soon in the next video, inshallah. Okay, bye bye. Stay safe.